All right. Hello, everyone. Welcome to my presentation. My name is Akila Ashokan, and I am a second-year graduate student at UIUC. In today's presentation, I will be discussing how sensory spaces are organized in fictional literature, specifically the various sensory patterns we can observe in each literary period by analyzing linguistic patterns in text data. First of all, I would like to talk about the broad impact of this work. Humans are social creatures that rely on senses to perceive the world and convey emotions. The organization of sensory spaces in different literary periods can give us clues about the perception of emotion throughout history and inform us about how to strengthen emotion and empathy in affective computing applications that rely on natural human emotion feedback. Fiction literature is unique in its ability to capture social norms by bringing to life sensory perception and emotional experiences. In literature, we commonly see examples of each of the sensory modalities used in literal and metaphorical manners. And by looking at this data, we can distill our goals into two research objectives. One is, how is the sensory semantic space organized in each literary period? And the two is, what are the general sensory interactions seen across all literary periods? Our dataset looks at a Gutenberg Dammit corpus based on the Project Gutenberg collection. And this dataset also provides official metadata about these Gutenberg texts, which we can use to narrow down fiction books that have English as the only language in the text. The publication date of each book was not included in the metadata, so we utilized the author's birth data to assign each text in the corpus to a literary period. We excluded any text prior to the 1500s and focused on texts from the 1700s, 1800s, and 1900s for further analysis. With these requirements, we had over 7,000 texts assigned to each of the literary periods, and the breakdown of the entire corpus can be seen in Figure 1. We also selected a set of 200 non-overlapping seed words that are semantically and morphologically linked to each of the 5 sensory modalities with the help of the WordNet lexical database. And these seed words were used to select context windows for each of the sensory modalities, which form the data for our vector space semantics model. So any words considered within a window of plus or minus 4 around a seed word are considered part of the context word. We extract the context windows for all 5 sensory modalities in all 4 corpora, and then we train a word-to-vec model using this data. Then we use the Pearson correlation to calculate the semantic identity and opposition and normalize to a 0 to 1 scale. We then eliminate the noise in our final visualizations by ranking the words using the term frequency inverse document frequency metric and consider only the top 200 words to plot out for further analysis. And to bring out these strong patterns in this complex data set, we use the principal component analysis on these top 200 words and then plot them as you can see in Figure 2 here. Now I'd like to move on to the results of this study by looking at each literary period and then zooming out to look at an analysis of all the literary periods. The PCA plots shown in Figure 2 allow us to visualize the top 200 descriptors by reducing the dimensionality of the word vectors down to 2 components. This dimensionality reduction does not discard any samples or characteristics and displays clusters of words based on their similarity. The corpora on the upper left shows the PCA plot for the 1700s. And from the left to right, we can see the strong mixed modality characteristics among touch, taste, and smell. It is largely created by literal forms of these senses like body parts. As we move towards the right, we see the dispersion of hearing and sight descriptors that represent more metaphoric meanings like stroke of affection, strike the blow, or sour his temper. The lack of clusters towards the right could indicate that these metaphoric uses of these senses were harder to identify as being semantically similar. Then we move towards the 1800s, we see a similar dispersion of sight descriptors this time to the left side of the plot that gradually mingles with touch and hearing descriptors. As we progress towards the right, there is a dense cluster of multiple sensory interactions seen in this period with less obvious sensory groupings. The 1900s is marked by more clear transitions between each of the sensory modalities and a very similar trend to the 1800s, but with smell descriptors scattered towards the right this time. Finally, we examine the PCA plot for the entire corpora. We notice that this plot looks very similar to the one of the 1800s, which encompasses more of the text from our fiction dataset. The same general pattern of sensory modality transitions is seen here also. When analyzing each of these literary periods, we were surprised to find that a common pattern emerged in sensory interactions across all periods. The senses appear to interact on a manner similar to concentric circles or onion layers, following the same smell, taste, touch, hear, sight ordering, with a slight variation in the 1900s. We highlight that this pattern does not necessarily constitute a hierarchy, but that consistent appearance of a sense ordering seems to indicate that we prefer using some senses in conjunction with others or less with another sense. In addition, we find that these findings might indicate we prefer to use certain senses more often in literal contexts over others, and metaphors are more easily conveyed with a sense like sight or hearing, which have been shown to be perceived this way. To further understand how these sensory modalities shape the way we perceive our world, we plan to continue our study of this area by analyzing texts utilizing new empirical methodologies that are arising in computational linguistics and natural language processing. To hear more, feel free to visit our poster on April 1st at 9:30 a.m. Central Time. Thank you for listening.